Excel spreadsheets rarely make mistakes. It is the people and processes around them that create risk. In this episode, I will show you 5 real stories in which spreadsheets did not fail technically, but failed as the basis for financial decisions. I will also talk about what needs to be changed in your organization to avoid these mistakes. Quick intro, if we haven't met. My name is Michael. I'm a lawyer and economist by education and a business consultant and analyst by profession. I run a company called Prezzo. You can check it out by clicking in the link in the episode description. We specialize in transfer pricing and business analysis, and we help small and medium-sized companies to grow by using proven and legal solutions. We work with over 100 companies a year, tech startups, manufacturers, online retailers, and I really understand that you all need clarity and specifics. You need real answers and recommendations. That's like what this channel is about, and that's what Prezzo is about. Let's continue. In boardrooms, finance departments, and maybe when discussing investments, tools are rarely discussed. The conversation is almost always about numbers, like revenues, costs, margin, risks, liquidity. Numbers appear in presentations, reports, and recommendations. They are treated as facts, as an objective description of reality on the basis of which decisions with real financial consequences are made. The problem is that very often the source of these numbers is a manually maintained spreadsheet, not as an auxiliary tool, but as a central element of the budgeting, forecasting, and reporting process. And this is not a matter of taste or technological fashion. It is a matter of operational risk, which at some point ceases to be abstract and begins to materialize in financial losses, wrong decision, and reputational crisis. This episode is not about demonizing Excel. Excel is one of the best calculators ever created. It is about showing where its useful role in finance ends and where manual work on data becomes a systematic threat. To understand this properly, we will go through 5 real documented stories. Each of them shows a different error mechanism, but they all lead to the same conclusion. The first story is probably the most famous example of a spreadsheet error in modern financial history, namely the case of JP Morgan and the so-called London Whale. The year is 2012. JP Morgan Chase, one of the largest and best managed banks in the world, conducts trading activities through its London branch of the chief investment office. The team manages a huge portfolio of derivatives, and the key element of risk control is the value at risk model. It is on the basis of VAR. The board and the management assess whether the level of risk is acceptable. In this case, this model was maintained in Excel. Not a simple spreadsheet, but as a complex model based on several files, manual data copying, and manual formula modification. In the course of changes to the model, errors occurred in the formulas resulting from copying and modifying the spreadsheet. Some of the volatility was underestimated, which made the reported risk level appear much lower than the real one. The report sent to the management did not raise any alarms. The numbers were consistent, the spreadsheets added up, and there were no technical errors. The problem was that the model presented like a false picture of reality. Decisions were made in a good faith, but based on data that appeared to be reliable. As a result, the bank suffered losses of between $6 and $6.5 billion. Subsequent reports by regulators and internal audits left no doubt. It was pointed out that the model was maintained manually. There was no automation of data flow, no version control, and Excel was used as a critical tool for the decision-making process. This was not the mistake of a single analyst or a single error in a cell. It was a flaw in the architecture of data processing. Second story shows that similar mechanism operates only in investment banking, but also in much more mundane planning processes. Let's move on to the 2012 Olympic Games in London. The organizers are planning the sale of tickets for the swimming competitions. The number of seats, availability, division into sessions, all this is planned in spreadsheets. The data is entered manually without automatic logical validation, without a system that checks the consistency of the plan with the actual capacity of the revenue. In one of the spreadsheets, in one of the cells, instead of 10,000, 20,000 was entered. Excel did not report an error because from its point of view, everything was correct. The sales system accepted the data as valid and began to sell the tickets. As a result, approximately 3,000 tickets were sold for seats that did not physically exist. The consequences were immediate. The need to transfer spectators to other events, refunds, organizational chaos, and of course, an image crisis. This is a classic example of so-called fat finger error. So a single entry error that ruins the entire plan. The problem was not that someone made a mistake. The problem was that the process was designed in such a way that a single mistake could pass through the entire system without any safeguards. The third story concerns public administration and shows how forecasting errors can translate into real budget decisions. In 2012, in the Utah Office of Education forecast the number of pupils in public schools. On this basis, the so-called weighted pupils were created, which was crucial for the algorithm for distributing funds between school districts. The forecasting model was based on an Excel spreadsheet with manually maintained formulas and a static approach to data. An error appeared in the weighting calculation, which was not detected at the reporting stage. The spreadsheet calculated correctly, the totals were correct, but the logic was flawed. And as a result, the entire budget was based on a false picture of financial needs. The scale of difference was approximately $25 million. Budget adjustments, changes in the allocation of funds, and of course, political explanations were necessary. This is a very good example of why forecasts and rolling forecasts should not be based on static spreadsheets where the model, data, and presentation are mixed in a single file. The fourth story does not concern a single spectacular error, but a whole class of problems that regularly appear in city and municipal budgets, especially in Canada and the States. In many cases, the budget is composed of a dozen or several dozen spreadsheets prepared by different departments. There are different versions of files, different templates, and no single source of truth. In one city, an outdated version of a spreadsheet was included in the budget package, resulting in differences of several $100,000 in key items. In another case, a misplaced column forced the city council to remove the budget resolution from the agenda. In yet another case, the omission of a single item in the spreadsheet generated a deficit of nearly $900,000. These are not stories about human incompetence. These are stories about process that cannot cope with versioning, consistency checking, and data aggregation. Excel is not a tool, but a bottleneck. The last story concerns characters error, which are particularly dangerous because they are often difficult to detect visually. In the case of Fidelity and other financial institutions, there were situations where in dividend forecast sheets or available funds, the minus sign was treated as a plus. Excel performed the calculations correctly, but based on incorrect assumptions. In one case, dividend payments of approximately $2.5 billion were announced, which in reality were not available. This illustrates a fundamental feature of Excel. Excel does not understand the business context. It doesn't know what is possible and what's not. It just calculates. All these stories lead to one conclusion. Excel is not bad, It is a brilliant calculator and a flexible analytical tool. The problem starts when Excel becomes a database, a reporting system, and the only source of truth in budgeting and forecasting processes. In finance, it's not about the numbers adding up. It's about them being true. That's why data should be fed automatically. The model should be separated from the presentation, and Excel should be used where it belongs as a final tool, not the foundation of entire decision-making process. After this series of stories, it is natural to ask if Excel generates so much risk is the only alternative to implement an expensive enterprise-class system. Is a small or medium-sized company doomed to manual spreadsheets until it grows to the size of a corporation? The answer is no, and this is crucial. The problem is not Excel itself, but the role we have assigned to it. Excel works very well as an analytical and presentation tool. Disasters begin when Excel becomes a database, a system integrator, and the only source of truth about the company's finances. So the first and most important step is to separate the moment of data entry from the moment of data analysis. In most companies, these two stages are currently mixed. Data is manually copied from the accounting system, cleaned, corrected, mapped, and analyzed in the same file. This is exactly the moment when the risk of fat finger errors, misaligned columns, incorrect formulas, and version chaos arises. The easiest way to actually implement some changes to this problem is a layer of automation. In Microsoft ecosystem, the role of this automation goes with Power Query. This is an ETL type of software that can eliminate the copy-paste as a method of system integration. In practice, data from the accounting system, whether it is like Optima, Enova, SAP, D365, or any other, is automatically exported to a CSV file or XML file or saved in a specific folder. Power Query then gets the data, clear it to the formulas, and prepare the categories for management. You just need to click the refresh button. No more like manual rewriting. This is no risk of someone pasting the data into the wrong column anymore. The difference in practice is enormous. A monthly report that previously took 2 or 3 working days to complete can now be generated in a few minutes. More importantly, the risk of manual error drops to almost zero because humans are no longer part of the data flow. This is exactly the moment when Excel ceases to be a place where data is created and becomes a place where data is analyzed. The second step is to change the way data is presented. One of the reasons why errors in Excel remain invisible for so long is that traditional tables mask the problems. 50 rows and a dozen or so columns give the impression of completeness, but in practice make it difficult to spot deviations. So we are now only interested in places where reality deviates from the plan. Tools such as Microsoft Power BI allow you to build dashboards that are visually empty as long as everything is going to the plan, according to the plan. The dashboard, when something goes wrong, like except from the plan, then the dashboard starts to scream. Instead of explaining 15 numbers, now you can focus on a problem and its cause. For example, a waterfall chart works particularly well here. Instead of comparing 2 columns of numbers, you show like a cause and effect sequence, the initial budget and the impact of the decline in sales, the impact of cost saving. So for the decision maker, this is the difference between a 15-minute explanation and a minute of understanding the entire situation. The third element of change is moving away from the annual budget as the main planning tool. In today's world, the annual budget becomes outdated very quickly. In practice, by March or April, it is already more of a historical document than a plan. The alternative is a rolling forecast. So modern analytical tools also allow the use of forecasting algorithms, such as exponential smoothing, which automatically detects trends and seasonality in data. The system learns the sales to fall in February and rise in December, and takes that into consideration in forecasts. These functions are built into Power BI or available in specialized SaaS tools like Phantom or Float. So the fourth area, particularly important for companies operating in capital groups, is ongoing monitoring of profitability in terms of transfer pricing too. The traditional approach is to check at the end of the year whether the margin is within the market range, and if not, to adjust the transfer prices. The problem is that such an adjustment often means a one-off cash transfer and negative impact on cash flow. As alternative is a real-time adjustments like margin monitoring. For example, on a year-to-date basis, using simple visualizations such as a bullet chart, this shows not only the current margin, but also the safe benchmark range. If it is already apparent in October that the company is approaching the lower limit, corrective action can be taken in the last quarter instead of making drastic adjustments after the end of the year. Finally, it is worth emphasizing one thing. The transformation of budgeting and reporting is not about replacing one tool with another. It is about changing habits. It is about moving from manually accounting for history to actively navigating the future. So Excel still has its place in this world, but it is at the end of the process, not at its center. If we bring all these stories, tools, and examples together, a fairly coherent picture emerges. These are not isolated mishaps or exotic cases from large corporations. This is the statistical norm of working with data based on manual spreadsheets. According to research by the European Spreadsheets Risk Interest Group, over 90% of spreadsheets used in companies contain errors. Not typos, but logical errors in formulas, ranges, and dependencies. Importantly, most of these errors are never detected because the spreadsheet works. The totals add up and the report looks credible. This means that the risk is not that Excel will crash, but the incorrect numbers will be treated as true. In turn, analysis of financial processes shows that manual preparation of monthly reports takes 2 to 5 working days each month in a small and medium-sized companies. After implementing automatic data, retrieval and fixed transformation rules, this time is reduced to few minutes needed to just refresh the data. This is not a marginal saving. On an annual basis, this is a dozen of working days saved. So research on operational errors also shows that manual processes generate from a dozen to even 20% of errors at the data processing. This is precisely the difference that determines whether management makes decisions based on a reliable picture of reality or on an aesthetic but false report. If we look at it from a decision-making perspective, the biggest change is not the implementation of any kind of tool itself, but the shift from reacting to the past to managing the future. Rolling forecasts, dashboard based on the fresh data managed by exemptions. The company no longer finds about the problems after the fact. It begins to see them when something can still be done about it. If you are interested in this topic, subscribe to the channel, and I guess I will see you in the next one.